In this series of video, I'm going to introduce Fourier series and expansion. And first, I will introduce what trigonometric series is. It is a series of the form an cosine nx plus bn sine nx, and we sum them from n equal to 0 to infinity. And we define this series on the closed interval negative pi to pi. So, as sine 0x is 0 and cosine 0x is 1, we can simply define b0 as 0. So we obtain that the trigonometric series become like in this form. And if bn is 0, then it is called a cosine series because the sine term here vanish. And similarly, if an is 0 for all n, we call this series a sine series. And there are two quick and trivial facts. Well, first of all, using the triangle inequality, one can establish this inequality. And if an and bn absolute value are smaller than cn to the negative s power for some s greater than 1, c is a real number, then this sum become less than infinity, which means it converge. Well, if this converge, then by the Weierstrass M test, one can show that this one is indeed uniformly convergent. And also, each partial sum is continuous because they are the sum of the sine and cosine which are continuous. And if the trigonometric series is uniformly convergent, then the trigonometric series indeed is convergent, is also continuous on the closed interval negative pi to pi. And if I call the trigonometric series phi, then I claim that phi is a 2 pi periodic function. Why? Because sine and cosine are also 2 pi periodic, and so the trigonometric series is simply the limit of the sum of those sine and cosine, which are also 2 pi periodic, and so the trigonometric series itself is also 2 pi periodic. So this is the end of the video about Fourier trigonometric series, and the next video I will talk about the Fourier series. See you in the next video.